Hello viewers, welcome to MathTech. I'm Amish Sharma. In this video, we are going to solve questions 31 and 32 of Chapter 3 from the book Contemporary Abstract Algebra by Joseph Gallian. So without a delay, let's start. Question number 31. For each divisor k greater than 1 of n, let ukn is equal to x belongs to un such that x mod k equal to 1. For example, U321 containing the element 1, 4, 10, 13, 16, 19 and U721 containing the element 1 and 8. List the element of U420, U520, U530 and U1030. Prove that UKN is a subgroup of UN. Let H is equal to X belongs to U10 such that X mod 3 equal to 1. Is H a subgroup of U10? Now given UKN is equal to X belongs to UN such that X mod K equal to 1, which is further written as X congruent to 1 mod K or K divide X minus 1. Part 1. Now by the definition, this implies U420 is equal to X belongs to U20 such that X mod 4 equal to 1 or 4 divide X minus 1. Now we know that U20 containing the element 1, 3, 7, 9, 11, 13, 17 and 19. Now we have to choose those elements x belongs to U20 such that 4 divide x minus 1. Since 4 divide 1 minus 1, 4 divide 9 minus 1, 4 divide 13 minus 1 and 4 divide 17 minus 1. Here 1, 9, 13 and 17 are x belongs to U20. This implies U420 containing the element 1, 9, 13 and 17. Part 2. U520 is equal to x belongs to U20 such that x mod 5 equal to 1 or 5 divide x minus 1. Now we have to choose those elements of x belongs to U20 such that 5 divide x minus 1. Since 5 divide 1 minus 1 and 5 divide 11 minus 1, this implies U520 is equal to 111. Part 3. U530 is equal to x belongs to U30 such that x mod 5 equal to 1 or 5 divide x minus 1. We know that U30 containing the element 1, 7, 11, 13, 17, 19, 23 and 29. Now we have to choose those elements of x belongs to U30 such that 5 divide x minus 1. Since 5 divide 1 minus 1 and 5 divide 11 minus 1, here 1 and 11 are x belongs to U30. This implies U530 containing the element 1 and 11. Part 4. U1030 is equal to x belongs to U30 such that x mod 10 equal to 1 or 10 divide x minus 1. Now we have to choose those elements x belongs to U30 such that 10 divide x minus 1. Since 10 divide 1 minus 1 and 10 divide 11 minus 1, this implies U1030 containing the element 1 and 11. Part 5. We have to check whether UKN, where k is greater than 1, k is divisor of n, is a subgroup of UN or not. As k, where k is greater than 1 and k is divisor of n, divides 1 minus 1. Here 1 is x belongs to UN. This implies 1 belongs to UKN. This further implies UKN is not equal to 5. Let a comma b belongs to UKN. This implies a is congruent to 1 mod n and b is congruent to 1 mod n. Since a is congruent to 1 mod n and b is congruent to 1 mod n, this implies ab is congruent to 1 mod n. Why it is so? Because if a is congruent to b mod m and c is congruent to d mod m, then ac is congruent to bd mod m. This implies ab belongs to UKN. As a comma b are arbitrary element of UKN, this implies ab belongs to UKN for all a comma b belongs to UKN. Therefore, by finite step subgroup test, UKN is a subgroup of UN. Hence, UKN, where k is greater than 1 and k is divisor of n, is a subgroup of UN. Part 6. Given h is equal to x belongs to U10 such that x mod 3 equal to 1. This implies h is U310. Since 3 is not a divisor of 10, this implies U310 is not a subgroup of U10. Hence, H is not a subgroup of U10. Question number 32. If H and K are subgroup of G, show that H intersection K is a subgroup of G. Can you see that the same proof shows that intersection of any number of subgroup of G, finite or infinite, is again a subgroup of G? The following result is very useful to learn in order to solve the question. Result: the identity element E of H, which is a subgroup, and G, which is a group, is same. Part 1. Let H and K are two subgroups of G. Now E, which is the identity element, belongs to H and K. This implies E belongs to H intersection K, which is further implies H intersection K is not equal to phi. Let A comma B belongs to H intersection K. This implies A comma B belongs to H and A comma B belongs to K. This further implies AB inverse belongs to H and AB inverse belongs to K. Why it is so? Because H and K are subgroups. This implies AB inverse belongs to H intersection K. Thus, AB inverse belongs to H intersection K whenever A comma B belongs to H intersection K. Hence, by one-step subgroup test, H intersection K is a subgroup of G. Part 2. Let H is equal to intersection I varies from 1 to infinity Hi. This is the collection of intersection of infinite subgroups, say Hi. Since E belongs to Hi, I varies from 1 to infinity. This implies E belongs to intersection I varies from 1 to infinity Hi, which is equal to H. This further implies H is not equal to phi. Let A comma B belongs to intersection I varies from 1 to infinity Hi, which is equal to H. This implies A comma B belongs to Hi, where I varies from 1 to infinity. This implies AB inverse belongs to Hi, I varies from 1 to infinity. Why it is so? Because all Hi are subgroups. This further implies AB inverse belongs to intersection I varies from 1 to infinity Hi, which is equal to H. Thus, AB inverse belongs to intersection I varies from 1 to infinity Hi, which is equal to H, whenever A comma B belongs to intersection I varies from 1 to infinity Hi, which is equal to H. Therefore, intersection I varies from 1 to infinity Hi, which is equal to H, is a subgroup of G by one-step subgroup test. Similarly, we can show that the collection of intersection of finite subgroup is again a subgroup of G. Hence, intersection of any number of subgroup of G, finite or infinite, is again a subgroup of G. Thank you very much for watching my video. If you like the content, please do like, share and subscribe my channel. If you have any query, comment me. Thank you very much.